Okay, we're at number 3, and we're trying to find the exact value of the following trigonometric expression using the trigonometric, angle addition, or angle subtraction formulas, and a combination of special angles. Special angles obviously referencing 30, 45, and 90 or 60 degree reference angles. So when we look at this, we look at 105 degrees and we think, how could I make this add or subtract 105 using angles that we know the sine and cosine of? So when you think about that, I just start at the beginning and say, okay, I have 30-degree angle, and then 45, and then 60. And right away, I see that 60 degrees and 45 degrees could add up to 105. So I'm going to rewrite this as sine of 60 degrees plus 45 degrees. And remember, we have a formula for the sum of a sine. So it's sine of alpha plus beta is, remember, sine is social and agreeable, so sine of alpha, cosine of beta, keeps the same sign since it's agreeable, and then it would be cosine of alpha, sine of beta. So when we write this out, we would have sine of the 60 degrees, cosine of the 45 degrees, plus cosine of the 60 degrees, times sine of the 45 degree. So sine of 60 degree would be the y value here, and that is, remember, a very tall angle, so that's the square root of 3 over 2, 1. And then cosine of 45 degrees is square root of 2 over 2, plus cosine of 60 degrees is the x length right here for 60 degrees, so that's the smaller side of the triangle, so that's the 1/2. And then square root of 2 over 2 again for 45 degrees. So this is square root of 6 over 4 plus square root of 2 over 2, or excuse me, 4. 2 times 2. So my final answer is going to be square root of 6 plus square root of 2, which you cannot add together since they're not like radicals, all over 4. Okay, there's that one. Okay, for number 4, we're finding the solution of the equations that are in the interval 0 to 2 pi, so we're not finding the plus 2 pi in now. We're only giving answers between 0 and 2 pi, but not including 2 pi. So then when we look at this one right here, the tangent 2 theta plus tan theta equals 0, the best way to solve this one would be to convert tan 2 theta to its equivalent formula. You can't solve them or factor out a tangent right now because they don't have the same insides. So tan of 2 theta, when you convert it, is tan of theta plus tan of theta, because remember, tan of 2 theta is really tan of theta plus theta. So then this would be all over 1 minus tan times itself, so tan theta squared, plus this tangent theta equals 0. The top can be combined to be 2 tan of theta over 1 minus tan squared theta plus tan of theta over 1 equals 0. Okay, and then I am going to try to get a common denominator by multiplying this by 1 minus tan squared and 1 minus tan squared. So this would be 2 tan theta over 1 minus tan squared theta plus tan theta, because I'm going to go ahead and distribute this, minus tan cubed, because it's tan squared times tan to the first, over 1 minus tan squared theta equals 0. I can combine like terms on top. There's a 1 tan theta and a 2 tan theta. So that's going to be 3 tan theta minus tan cubed theta all over 1 minus tan squared theta equals 0. The next step we'd want to take is we want to see if we can factor anything out of the top. So this is actually sort of like a rational equation you would have seen in Math 136. I can pull a tangent out of the top, and I'd be left with 3 minus tan squared theta all over 1 minus tan squared theta equals 0. And this is where a 136 comes into play here, because you do not let your denominator equal 0 in a fraction. So we don't actually solve this path down here because we don't want our denominator to ever equal 0. That would be undefined. So we're only going to be solving the top. So this would be either tan theta equals 0 or 3 minus tan squared theta equals 0. Tan theta equals 0 happens at the angle of 0 and at pi, because on your unit circle, those have points 1, 0, and negative 1, 0. And remember, tangent is y over x. It's opposite over adjacent. So then for this one, we need to subtract over the 3 and then divide by the 1. We've already done this example once before already in a video. Then we take the square root of both sides. So this is plus or minus square root of 3 over 1 if you want to think of it as fraction. So remember, that's the plus or minus square root of 3 over 2 and 1/2. So we have two different equations to solve. Tangent of theta equals positive square root of 3 over 2 over 1/2. And tangent of theta equals the negative version of that. So remember, if you're square root of 3 over 2, first of all, tangent is positive in quads 1 and 3. And if your opposite is square root of 3 over 2, that means you're dealing with a 60-degree angle. So this is pi over 3, which means this is 4 pi over 3 down here. And this is going to be the same, but in the other two quadrants. So we're going to get a 2 pi over 3 for quad 2 and a 5 pi over 3 for quad 4. Okay, that's all there is to that one. And that one's a tricky one. Honestly, the sine and cosine ones are a little bit easier in that situation. So for this one, the directions say we're going to be using the exact value of the following trig expression using half angle formulas. So we have to think that this already is the half angle. So what they're saying here inside here is that 75 degrees is theta over 2, which means that the original theta, the one that would be used in the formula, is double this. So 2 times 75 is 150 degrees. Now, something to do with half angle formulas. Remember, all of the half angle formulas have two things going on. They have a plus or minus in front of the square root, and then inside they only use the angle of actual theta, not theta over 2. So this plus or minus outside, theta over 2 tells you in that wherever quadrant that is located in, and whatever trig function it is, so if it's sine, cosine, or tangent, that will tell you whether or not you should choose a plus or minus right here. And then the theta inside is, remember, going to be the angle that we draw, like the 150 degrees here. It's going to be the cosine of that angle, whatever that is. So just kind of not, without writing all the formulas down, that's kind of what's going on here. So we're going to be looking at, we need to figure out, first of all, 75 degrees is theta over 2. And in quad 1, which means tangent would be positive here. So when we go to pick our plus or minus, we're going to pick a positive because of that. Okay, that's all we needed to know about the half angle. For the actual formula, we need to locate cosine of 150 degrees. So cosine's over here, and 150 degrees would leave you with a reference angle of 30 degrees. So this was the 1/2, and this is square root of 3 over 2. But in this quadrant, that's negative, that's positive. So cosine is the x value, so that's going to be negative square root of 3 over 2. Once you have all of your information, you need to know your half angle formula. So tangent of a half angle, which for us is the 75 degrees, is equal to plus or minus, which we're going to choose plus because we already determined that, the square root of 1 minus cosine theta over 1 plus cosine theta. So this is going to work out to a positive square root of 1 minus negative square root of 3 over 2 over 1 plus negative square root of 3 over 2. We typically do not like the fractions within fractions, so we're going to multiply everything on top by a 2, and whatever we do to the top, we have to also do to the bottom. We're choosing 2 because it'll clear out those little fractions. So this would be square root of 1, and that's plus now because that's negative, negative. So plus the square root of 3 over 1, and this is plus minus multiplied, so that's going to be minus the square root of 3. So there would be my answer for 5C. Now, if you notice on the answer key, I believe that gets rationalized. I am not going to get that nitpicky with you. If you don't do that, I'm not going to lose my mind. But I'll show you how they do that. They would multiply the top and bottom by the conjugate of this one on the bottom. So 1 plus the square root of 3. So then you get a 1 plus the square root of 3 to FOIL out on top. So that's going to be 1 plus 2 square root of 3 plus a 3. And then on the bottom, or actually you could just write it as squared. That'd be easier. So on the top we would have 1 plus square root of 3 squared. On the bottom we'd FOIL it out. So this would be 1 plus square root of 3 minus square root of 3 cancels out, and then minus square root of 3 times square root of 3 is square root of 9, so just minus 3. So then this becomes square root of 1 plus square root of 3 squared all over negative 2. And somewhere, oh, I know what I messed up. These were 2's. Caught myself. 2 times 1 is 2. If you don't distribute, you get in trouble. So these are both 2's. Okay, that's why this wasn't working out to a perfect square down here. Rewind. Happens to us all. Okay, so I'm supposed to distribute the 2 to both of these, but I didn't distribute it to the 1s. So if I multiply both of these by 2 plus the square root of 3, on top you're going to get 2 plus the square root of 3 squared. On the bottom you get 4, 2 times 2, minus the square root of 9, which is minus 3. So you're going to get a 1. That makes a lot more sense. So then this is square root of just 2 plus square root of 3 squared. So the square and the square root cancel out, which makes this just 2 plus square root of 3. I'm really okay if you stop here, but this is the algebra of rationalizing that completely out. And this is going to be the end of part 2.